Good morning. Welcome, Sham Stars. In continuation of chapter Force and Laws of Motion, today we will learn second law of motion. In previous video, we learned first law of motion and inertia. Inertia is the tendency of any object to resist the change. If it is at rest, it tends to remain at rest. If it is moving, it tends to keep moving. Now let's understand inertia and mass. Mass is the amount of matter in an object. For example, a bowling ball has more mass than a tennis ball. The greater the mass of an object, the greater its inertia. Mass is the measurement of inertia. In other words, we can say that a heavier object has larger inertia than a lighter object. More massive the object, larger its inertia. Thus, quantitatively, mass of an object is a measure of its inertia. To understand momentum, let's talk about some examples. A truck at rest does not require any attention when parked along a roadside. But a moving truck, even at the very slow speed, may kill a person standing in its path. Let's take one more example. A person may play with the bullet in his hand. However, the same bullet, when fired from a gun, may kill that person. These observations suggest that the impact produced by the objects depends on their mass and velocity. Now we can define the momentum. The momentum of an object is defined as the product of its mass and velocity. The relation for linear momentum is P is equal to mv, where P is momentum, m stands for mass, and v stands for velocity, where p and v are the vector quantities. It means momentum has both direction and magnitude. Its direction is the same as that of velocity. The SI unit of momentum is kilogram meter per second. Now let's understand Newton's second law of motion. It connects force, acceleration, and mass. It explains that an object acted upon by a force will accelerate in a direction of the force. Acceleration equals net force divided by mass. F is equal to ma. This slide shows mathematical formulation of second law of motion. Here, initial momentum is p1, final momentum is p2. Initial velocity u, final velocity is v. Acceleration is change in velocity per unit time, that is v minus u upon t. Change in momentum directly proportionate to p2 minus p1, or we can write mv minus mu. This can be written as mv minus u. Rate of change of momentum is directly proportionate to mv minus u upon t, that is acceleration. Or we can write applied force is directly proportionate to m change in velocity, that is a. Or we can write force is equal to kma, where k is the constant of proportionality. The SI unit of mass is kilogram and SI unit of acceleration is meter per second square. The unit of force is so chosen that the value of constant k becomes 1. For this, 1 unit of force is defined as the amount that produces the acceleration of 1 meter per second square in an object of 1 kilogram mass. Thus, the value of k becomes 1. So, F is equal to ma. According to mathematical formulation of second law of motion, we can say that the force acting on an object is equal to the product of mass of the object and the acceleration produced in it by the force. The force acts in the direction of acceleration. So, 1 unit force is the force which produces unit acceleration in an object of unit mass. Or we can say force is said to be 1 SI unit which produces an acceleration of 1 meter per second square in an object of 1 kilogram mass. So children, this is all about second law of motion. I hope you must have understood. In the next presentation, we will talk about third law of motion and conservation of momentum. Thank you, Shem Stars. That's all for today. You can drop your queries on Google Classroom. Take care.